Alright, so I think I'm recording. Let's take a look at problem number 7 on finding the inverse. Actually, we want to do two things. We want to find the inverse and then determine if that inverse is a function or not. Alright, so when I look at this, I see that this is a transformation on a parent function of the square root function. I know that I have a parent function, the square root of x, and that this graph has been shifted to the right 4 units, then vertically stretched by a factor of 3, and then shifted up 5 units. So if I think about what this is going to look like, originally the square root function looks roughly like that. Well, the minus 4, it's bizarre in its behavior, it's going to actually shift to the right 4 units. Then the 3 is a vertical stretch by a factor of 3. So it stretches away from the x-axis. All of the y-coordinates get multiplied by 3. Well, on the x-axis, the y-coordinate was 0. When you multiply it by 0, that's why it's pinned at this point, and it's stretched away from the x-axis. And then finally, this thing is lifted up 5 units as a rigid structure, so this point that's 4, 0 gets lifted up to 4, 5. And I don't know, maybe I'll change colors here. My final, this g of x is going to look something like this. And I even know the coordinates of this point has to be 4, 5. Okay, well, from there, I can identify the domain and range of this function g. I know that every point on this graph, the x-coordinate of every one of those points is to the right of 4. All of those x's are greater than or equal to 4, because I have one that equals 4 right here at that starting point. Now, the y-coordinate at that point is 5, and I notice that the y-coordinates of every point on this graph are all above 5, meaning that all of those y-coordinates are greater than or equal to 5. Okay, and finally I notice that this function is a one-to-one function, because it being a function, the square root function, I knew it passed the vertical line test, but it also passes a horizontal line test. You can't find a horizontal line that intersects that graph more than once. So why am I interested in this being a one-to-one function? One-to-one functions have inverses that are also functions. In fact, they have inverses that are themselves one-to-one functions. So when I do find the equation for this inverse, I can immediately say this inverse is a function, and even more detailed, in fact, it's a one-to-one function. Alright, so let's find the technique, the idea of an inverse is to switch the domain and range. So that means switching x and y, and not just a single point, everywhere. Instead of using function notation for a minute, I'm going to go back and just use x and y notation. So if I switch the variables x and y, everywhere I see a y, I write it as x. Everywhere I see an x, I write it as y. In my equation, I'll have this. And also, on this this is describing my domain and range as an inequality, not our interval notation, but you get the idea that greater than 4, we were writing it as 4 to infinity in interval notation. I just write it as x greater than or equal to 4. But now it's not x greater than or equal to 4, it's y greater than or equal to 4. And over here, it's no longer a y greater than or equal to 5, it's x greater than or equal to 5. Alright, so now I need this equation to be solved in terms of y. Right now it's in terms of x. I need to get y by itself. When I look at the right hand side of this equation, I see two terms. The term of interest is this first term because it contains the variable y. I need to get rid of this other term, and by getting rid of it, I need to move it to the other side of the equation. I need to subtract 5 from both sides of the equation. When I subtract 5 from the left, I get x minus 5. When I subtract 5 from the right, the positive 5 and negative 5 will cancel, and I'll just have that first term, which is what I wanted. Now if I look at this, I have multiplication. So with multiplication, we talk about factors. I have a factor of 3, and then I have this factor that's the radical, the square root. I need to get that square root by itself because that contains my variable of interest. That contains y. So I'm going to divide both sides of this equation by 3. On the left, when I divide it by 3, I'm just going to write it as x minus 5 over 3. On the right, when I divide by 3, 3 divided by 3 is 1. And I just get this square root of y minus 4. So now I need to get rid of that radical, that square root. So to get rid of the square root, I square both sides of this equation. Now, I'm going to switch sides here. And instead of having the y minus 4 on the right hand side, I'm going to switch it over here to the left hand side because the radical is now gone. And this guy, well, this fraction, the numerator, I'm not going to bother foiling that out. I like it in factored form. It's going to help me in a second to determine the vertex of what we see that this is heading towards being a parabola, y equals x squared, and I'll be able to read my vertex from my graph if I leave it in factored form. Now the denominator, I am going to square it, and 3 squared is 9. Okay, so if I add 4 to each side, then I have this, to divide by 9 is the same as to multiply by 1/9, and I have x minus 5 squared plus 4. Now remember, I normally, this restriction comes along for the ride after each equation, but to tell you the truth, I'm lazy, and I usually don't write it again until I get down here to the very end, or just occasionally write it. But this is in this y greater than or equal to 4 and x greater than or equal to 5 is implied all the way through my work. All right. So let's take a look at what this new graph is. Remember, we had sketched the old graph to the square root. We'd shifted it to the right and then shifted it up. Well, here I know that this function, this inverse, its parent function is f of x squared, our quadratic function. The graph is referred to often as a parabola. I know that minus 5 that you apply before you apply the function, before you square it, you're affecting the domain, and that's actually, even though it says minus 5, it's a shift to the right 5 units. So I know that vertex that was at the origin is now over here at 5, 0. The 1/9 is a vertical shrink by a factor of 1/9. So my parabola is going to open a little bit wider with that being 1/9, because the vertical distance away from the x-axis, all of those distances have been divided by 9. You know, to divide by 9 is the same as to multiply by 1/9. Well, finally that plus 4 is going to shift this up 4 units. So if I draw my parabola like this, I've got a little bit of a problem, because remember that our original function was not only a function, it was a one-to-one function. So we know that the inverse is going to be not only a function but a one-to-one function. This parabola is a function, but it fails the horizontal line test. But see, as I've graphed it, I haven't paid attention yet to this x greater than or equal to 5. If we went up 4 units, this was 4. So my vertex is here at 5, 4. Well, we want every point on the parabola that have an x-coordinate bigger than or equal to 5, not less than or equal to 5. So on the left half of this parabola, I need to erase it. That's not part of this function. When I switch the domain and range, I now have restricted x. I have this new domain that's not defined by our traditional, the domain is a set of all real numbers, excluding division by 0, excluding taking the square root of a negative number. No, somebody has not violated those rules, but somebody has just came along and said, hey, let's tighten up this domain. I don't want it to be all real numbers. I want it to be greater than or equal to 5. I want it to be the right half of that parabola, right of the axis of symmetry. Reason for that is so that it will pass the horizontal line test. Now, I know that this function and the original function truly are inverse functions because each one of them is 1-to-1. So, my final answer has to include at least that x greater than or equal to 5. I normally also write the y greater than or equal to 4 because I normally identify the domain and range. And when I switch the domain and range, not only do I switch x and y, I have to switch x and y in the inequalities that describe my domain and range. So here is my answer for number 7. Being greater than 5, I know it's graphing the right half of a parabola that does pass the horizontal line test. Its inverse is a function. Well, up above is its inverse. Now, I suppose in my final answer, I probably need to go back to function notation and tell people that this is the inverse of g. That's not an exponent of -1. That's just the naming, that's just the notation that we use for the inverse if the original function is g. So I hope that helps. I'm going to do the rest of them on separate videos. I will talk to you later.